One of the most useful use cases of AI is online search. Instead of navigating various pages given to you by a search engine, you can give your query to an AI and immediately get an answer directly related to your question. Combine this with Retrieval Augmented Generation, or RAG, where the AI itself can perform a query on a search engine, you can get a more accurate answer with less chance of hallucination, along with sources. But this got me thinking, maybe AI is not the most useful part of this combination. Maybe the useful part is the fact that you don't have to navigate web pages to get your answer. What if you just had a search engine that gave you text-based answers? So this is exactly what I started building for myself. Of course, this would be a CLI tool because I primarily want to use this while programming, so I don't have to switch between terminal and web browser. This naturally also means that I only wish to extract text from my search results, no videos or images. Initially, I did not want to use third-party APIs to do this, so I opted to use SirXNG. This is a meta search engine that you can run on your own machine. It basically performs search queries on multiple online search engines and then re-ranks them. If you change the configuration to allow JSON output, you can then use it as a search API. So, the basic idea is, I start the program, enter a query and get a list of search results. I then choose one URL from the search results. That URL is then fetched, converted to Markdown and then displayed as text. Converting to Markdown essentially removes all HTML tags, JavaScript and other stuff that is not relevant for displaying information. I wrote this in Go using an HTML to Markdown library from Johannes Kaufmann. I experimented with a few TUI libraries for Go, such as TView, but found them to have bugs related to my use case or were otherwise unsuitable. I also attempted to just use raw CLI output with control sequences, but I've never used control sequences before and could not bother to learn them at this point. So I opted to use the Git approach. Instead of making my own complex user interface, I let another program, namely Vim, do the hard work for me. I format the search results to a text buffer, write the buffer to a temporary file, and then open it with Vim. Each search result is numbered, so when Vim is closed, we read the file again and look for a line that contains a single number only. If that number matches a search result number, we open the URL for that search result. Essentially, by creating a new line with only a number, we can use Vim as a selection interface. When a selection is made, the URL is fetched and the resulting HTML response is converted to Markdown, and then written into a temporary file again and opened in Vim. While Vim solved the UI issue easily, there's still a problem. Websites contain a lot more than actually interesting information, such as menus, headers, footers, things like that. A cheap solution for this is to use the content field provided by SirXNG API. Content is a small snippet of text taken from the page by the search engine. We can search for this text from the processed Markdown file to try and find where the relevant information starts. When we find the closest match, we can use the line number of the text to start Vim with a command that moves the cursor immediately to that line. We are not interested in an exact match, so we do a bit of pre-processing to improve our chances of finding a match. We split the content to words and convert these words to lowercase, and filtering out any special characters and whitespace. We do the same for Markdown content and then start searching. We get the largest sequence of matching words and return the line where this sequence occurs, and we use that. At this point, I already had a usable terminal command that I can use to do online search without the browser. I added some commands to open pages to enable navigation. A line that says "take me back" will open the search results again once Vim exits. Go to line can be used to open up another URL as a Markdown file. There is one big problem with this approach. Fetching a page only involves an HTTP GET request. In an ideal world, this would be sufficient to use web pages, but because of the modern web, everything needs 2 megabytes of JavaScript to display a bunch of static text, so some pages are not loading properly. To get around this, I would need to fetch the pages with the headless browser instance that can also run JavaScript, which sounds like a more complex project, so maybe another time. The next experiment I wanted to try was to just use Brave Search API. Not specifically Brave, but any other search API designed for LLM context. I am not sponsored by Brave, but if you want me to have sponsors someday, increase that sub count for me, will ya? LLM context APIs would basically do what I am trying to do here. In addition to URLs in the search results, it also provides relevant text snippets from that search results, intended to be used for RAG with large language models. Sadly, signing up to Brave Search API requires you to provide payment details, and for some unknown reason my card was declined, so that was the end of that experiment. The free tiers have usage limitations anyway, so moving on. The search that I used to find an appropriate line in the Markdown file is a very simple one, so I decided to try making another, more interactive search method. I first tried to implement vector-based search, which was an interesting experiment. The problem was that it didn't work. It might just be a skill issue on my part, so perhaps I'll try using vector embeddings for some other purpose in the future. So eventually I replaced that implementation with fuzzy search, and that worked quite well. Basically, adding a search line to a page similarly with goto will trigger a search query on the page. The page contents are split into roughly 10 line segments, and then they are ranked based on how closely they match the query. This segment ranking is then displayed in the text editor. But that's it for this video. I managed to make a decent text-based search engine that I can use while coding. I've put the code to my GitLab profile if you want to check it out. Thanks, and see you next time.